number 3, so I cut it off that last video, and I'm going to redo it. And the mistake I made, as you can see, I guess I'm not going to, yeah, I'll cut it off the video, is that this is 245 degrees, okay? So we have, let's just go back, because obviously you didn't see that recording. We have an airplane flying at a bearing of 245 degrees. So the bearing is from the north and it's clockwise. So that's the 245 degrees. The 550 feet, or my gosh, the 550 miles per hour is going to be our magnitude in this situation. So when we did that whole vector, magnitude of vector v, and it's like cosine of theta, magnitude of v sine of theta stuff, that's what we're doing here, okay? So the problem is that we can't use 245 degrees because we are doing this off of what we're used to, and we're used to going from here and around, correct? So we have to figure out what that actually is. So to do that, we have to figure out what this value is. So if it starts here, it goes 180 degrees, correct? And we can basically say, okay, this is 180 degrees, so what's this chunk? So you can take 100 or 245 degrees and subtract it from 180, and you get 65. Okay, so that's 65 degrees. So if this is 65 degrees, what's this chunk? Well, 90 minus 65, and I could be overcomplicating this, is 25 degrees. So from here to here is 180. So this is 180 plus 25, and that gets you 205. So you really should have cosine of 205 degrees and sine of 205 degrees. Okay, so then you have to enter that into your calculator. So you type in 550 cosine of 205, and you get negative 498, negative 498.469. I'm going to go to 3 decimals. And then if you do 550 of sine of 205, then I do get negative 232.440. Right, so that's the answer for number 3. Okay, moving on to the next video, or to the next slide. You have a man pushing a lawnmower with a force of 25 pounds, okay, at an uphill angle of 40 degrees. So, the question is, how do we do this? Okay, so he's pushing a lawnmower at an uphill angle of 40 degrees. Okay, that's not a bearing of 40 degrees, so this is normal. This is the normal part, but what's the magnitude? Well, the magnitude's the force, okay? That's how much he's pushing it. So we're going to treat that like magnitude, okay? So it's the same thing we did as the last one. So to find this vector, we're going to do 25 cosine of 40 degrees and 25 sine of 40 degrees. Okay, when you do 25 cosine of 40 degrees, you get 19.151. When you do 25 sine of 40, you get 16.0696, which that makes it 070. Okay, so that is the first 4 examples. So not too bad. I'm actually going to break the video up here and then do the resultant force as a separate video. Okay, so see you in the next video.